Hello, this is Mr. Cunningham, and today we're going to be talking about Chapter 7, which is Ionic and Metallic Bonding. And in Lesson 1, we will be talking about ions. Now, ions are important because they're actually all throughout our body, and our body uses these ions to transmit neurological signals. So when your brain wants to tell your hand to move or your mouth to speak, those ions allow that message to be transmitted. So that's kind of why ions are important to life and to our world in general. So today we're going to be talking about ions, and then that will lead into ionic bonds. So ionic bonds contain ions, which are charged atoms. And in order to predict and to know the charge of ions, we need to understand two things. And the first of these things is valence electrons and how to find valence electrons. And you guys have spent a lot of time with Mr. Arbogast learning and figuring out valence electrons and what atoms have however many valence electrons. But just to kind of refresh our memory, we can find valence electrons by just looking at the periodic table. So if we are looking at calcium, which is in group 2A, then we know that calcium has 2 valence electrons. If we're looking at chlorine and it has 7, it's in group 7A, we know that it has 7 valence electrons. And that'll be important to the lesson that is coming up. The second thing that we need to do in order to predict and to know the charge of ions is to be able to draw electron dot structures. So here's how we do that. To make electron dot structures, the first thing that we need to do is draw the symbol. So what I've done here is drawn the symbols for sodium, magnesium, chlorine, and oxygen. So we've got the symbols drawn. The second thing we need to do is put dots around the symbol for the number of valence electrons. So sodium is a 1A group element, so it will have 1 dot for 1 valence electron. Okay, and magnesium is a 2A, so it will have 2. Oops. Chlorine, on the other hand, it is in group 7A, so it will have actually 7 little dots that surround it. So there's the 7 dots. And oxygen is a 6A element, so it will have 6 dots around it. So those are examples of how we can write electron dot structures. So the second thing that we need to know in order to predict the charge of ions is we need to understand the octet rule. And you've talked about this previously, but what the octet rule says is that atoms want to have an electron configuration of a noble gas when they form a compound. So let's look at that. Here we have 3 elements on the bottom. So let's look at the electron configuration for lithium. So lithium has 3 electrons. So on the left side here you have the 1s, 2s, 3p, and 3s orbitals. So it has 3 electrons, meaning that it has 1 electron in its 2s orbital. So in order to achieve an electron configuration that's a noble gas, it can either gain 7 electrons and get to neon, or it can lose 1 electron and get to helium. So which one would you think it would go to? It could gain 7 electrons, but that is a lot of electrons to gain. So what it actually does is lithium will actually lose this electron to have an electron configuration that is equal to helium. So now we have lithium here with 2 electrons, and that is the same as the electron configuration of helium.
Now we can show this loss of an electron with our electron dot structures. So this is how we would show that. So we have lithium right here, Li, and it has one valence electron. So what happens is we have a reaction here, and so we have a loss of one electron. And this is called ionization. And ionization simply means an element becoming an ion. So ionization. So what this happens is if we lose an electron, then we are still left with lithium, but now it has a positive charge on it. And we're also left with an electron. And this, right here, what I'm boxing off, is called a cation. And a cation is just a positively charged ion. We have to remember that an electron is a negatively charged particle. So when we lose an electron, that means that our element has to become positive. So in this case, lithium lost an electron, which is negative, so it becomes positively charged. So here we can do the same thing with fluorine. Now, remember when we said about the octet rule. The octet rule means that elements, when they form compounds, they want to achieve a noble gas electron configuration. So in the case of lithium, it wanted to lose an electron because that was the easiest thing for it to do. It only had to lose one electron to get in a noble gas electron configuration. In the case of fluorine, it will actually want to gain one electron. So here the only difference between fluorine, which is a halogen, and neon, which is a noble gas, is one electron. So what it will actually do is gain this electron right there to get in this electron configuration, because that's the most stable thing for it to do. So we can write this reaction just like we did with lithium, except this time we'll have fluorine, and remember it has 7 valence electrons. Okay, so there's our electron dot structure. But it is actually going to gain an electron. So when it gains that electron, it becomes fluorine with a negative charge, because remember, it gained an electron. And this right here that I'm boxing off is called an anion. An anion has a negative charge. So let's do a little bit of review. So here we have magnesium and we have oxygen. Magnesium is a group 2A, so it has 2 valence electrons. And oxygen is a group 6A element, which means it will have 6 valence electrons. So in the case of magnesium, what is the easiest way for it to achieve a noble gas electron configuration? The easiest way is for it to lose its 2 valence electrons. So it would lose these 2 electrons and become magnesium and a magnesium cation with a +2 charge. Now the reason it has a +2 charge is because it lost both of its valence electrons. So now let's go to oxygen. It has 6 valence electrons. So what is the easiest way for it to have 8 valence electrons. And the easiest way for it to have 8 valence electrons is to gain 2 electrons. So if we add in 2 more electrons, that means that oxygen has now gained 2 negative charges. So we can write oxygen as a -2 ion. And we would write these reactions using electron dot structures like this. So we have magnesium, and it starts out with 2 valence electrons. It reacts, it loses 2 electrons. So it becomes a magnesium cation with a +2 charge, and it's lost those 2 electrons. Now for oxygen, it'd be a little different. So it has 6 valence electrons. So what we have to do is add 2 electrons. And remember, this is a gain of electrons, which means we have a gain of negative charge. And it gained 2 electrons because it wants to achieve that octet rule. It wants to have a noble gas electron configuration. So then we're left with oxygen with 8 valence electrons and a -2 charge.
Well, this wraps up our lecture on ions. If you have any questions, I'd encourage you to write them down right now so you don't forget about them. And then next time when you see me in class, you can ask me those questions. The next section that we'll be talking about is actually ionic bonds. So be ready when you come to class, or whether I do a video lecture or not, just be ready for ionic bonding.